There is a number in tonight's NOAA data that no mainstream report has mentioned. It is not a dramatic number. It is not the kind of figure that appears in a crisis bulletin or a breaking news alert. It is a percentage embedded in a technical model update released by two of the most authoritative scientific agencies on the planet. We will reach it before this report closes. What it means for the 8 billion people living inside Earth's magnetic field is what tonight's report is built around. Something happened to the ground beneath you this year that no compass in recorded history had witnessed before. The North Magnetic Pole, the point toward which every compass needle on Earth has pointed since humans began keeping records of such things, crossed a threshold in the Arctic. This year that has not been crossed in more than 190 years of continuous scientific observation. It is now, for the first time in all of that recorded time, closer to Siberia than it is to Canada. An invisible line was crossed in the frozen north, with no sound, no shaking, no column of smoke, no breaking alert on any cable news network. And yet, the instruments that track it, the instruments that keep military aircraft on course over the polar ice, that guide submarines through depths where no other navigation is possible, that calibrate every smartphone that has ever told you which direction you are walking, those instruments required an emergency-grade update. Not because something broke, because the planet moved faster than the models predicted, and then moved in a way the models had never seen. That is what tonight's report covers. What is happening to Earth's magnetic field right now, as measured and confirmed by the National Oceanic and Atmospheric Administration in cooperation with the British Geological Survey, two of the oldest and most rigorously maintained geophysical monitoring institutions in the world. What the new data shows that the standard coverage of this story has not explained in full. What the monitoring infrastructure actually looks like, how it is built, why it matters, and what it is currently telling the people who build their navigation systems around it. And then, because we do not stop at the modern record, what the older layer says. There is an older layer. There always is, with events of this nature and this scale. Tablets pressed into clay before electromagnetism had a name. Oral traditions preserved across generations by people who had no satellite network but watched the sky with extraordinary precision. Manuscripts written in scriptoria by scholars who could not have known what a magnetic field was, but who described, in the language available to them, a world in which the sky stopped being what it had been. Those traditions, and those texts, and those specific passages will be examined tonight. The correspondence between what they describe and what the instruments are showing right now is documented in this report, carefully and without exaggeration. We do not tell you what it means. The data is on the record. The interpretation belongs to you. There is a specific text that addresses what happens when the celestial order departs from its prescribed course. It was written before compasses existed, in a language that had no concept of electromagnetic fields, by scribes who were recording something they had either witnessed or received a tradition about. That text will be examined in full before this report ends. We are not there yet. Before we go further, a few words about what this channel does and why it matters. If you are watching this report tonight, you found your way here because something in how we work is different from the news channels and the documentary feeds and the general commentary that covers these events. We work from official sources: NOAA, the British Geological Survey, the European Space Agency, the USGS, and we present the data in full, not in the truncated version that appears in most public coverage. And then we do the thing that no monitoring agency does, the thing that separates this work from everything around it. We go back to the full record of human observation and documented prediction before instruments existed, and we ask whether anything in that older record describes what the instruments are now measuring. The answer tonight is yes. It is on the record in at least 4 independent traditions spanning 4 different cultures and 3 different millennia. We will get there. If you find value in this kind of reporting, subscribe. We file every night. The data does not stop, neither do we. And tell us in the comments tonight where you are watching from. Not a casual question. The geographic distribution of our audience matters to the story in a way that will become clear before this report is finished. The full record starts now. What you are about to hear in this report was verified through official agency documentation, peer-reviewed scientific publication, and the scholarly literature of multiple academic disciplines. The event that is the subject of tonight's briefing is not a rumor, not a social media alarm, and not a tabloid claim. It is in the World Magnetic Model 2025. It is in the published statement of the British Geological Survey. It is in the NOAA documentation released to industry and government partners in January of this year. It is on the record. What tonight's work does is take the data that exists on that record, present it in full, rather than in the truncated form that most coverage provides, and then place it alongside a parallel record that the monitoring agencies do not file, the record of what human observation across 3,000 years documented when the directional framework of the world changed around it. Where you are watching from tonight matters. Geomagnetic events are not evenly distributed across the globe. Their effects are concentrated at specific latitudes, in specific geographic zones. The data we will examine tonight is directly relevant to people living in high-latitude regions of North America, Europe, Scandinavia, and Russia in a way that it is not equally relevant to people watching from the tropics or the southern hemisphere. When you tell us where you are watching from, you are not just participating in a channel community ritual. You are, in a small way, contributing to the kind of observational record that we will see the ancient traditions valued enough to preserve across millennia. The locations that people report matter. We track them. The World Magnetic Model, the document that tells every navigation system on Earth where magnetic north actually is, was updated in January 2026. The release came jointly from NOAA's National Centers for Environmental Information and from the British Geological Survey. These two agencies have maintained the model together since the early 1980s, building on a tradition of geomagnetic monitoring that stretches back through the 19th century. The current version is designated WMM 2025. Alongside it, for the first time in the model's history, a companion product was released, the WMMHR 2025, a high-resolution variant that increases the spatial fidelity of the magnetic model by a factor of 10. Previous versions of the model could resolve magnetic field variations down to approximately 3,300 kilometers. The new high-resolution version resolves them down to 300 kilometers. That is not a minor technical upgrade. That is the difference between knowing which hemisphere you are approaching and knowing which city. The reason for the tenfold increase in resolution is significant, and it is not the reason that most coverage of this story has identified. The model requires this level of precision because the magnetic field is now changing in ways that the previous resolution could not adequately track. The pole is moving. It has been moving for decades. But the specific way it is moving right now, the direction of the change, the rate, and the sudden reversal in that rate is behavior that the scientists who build the model describe in their own published and peer-reviewed language as something we have never observed before. That phrase, used by Dr. William Brown of the British Geological Survey in the official release documentation for the WMM 2025, is the center of tonight's report. There is a number in tonight's NOAA data that no mainstream report covering the WMM 2025 release has mentioned by name. That number is not the pole's current speed, which most outlets cited. It is not the pole's current position, which most outlets mapped. It is a specific measurement embedded in the updated model documentation related to a category of geographic zone that has quietly and measurably expanded since the last major model update. We will reach that number. Keep it in mind as the technical picture develops. Earth's magnetic north pole is not the same as geographic north, the fixed point at the top of the globe around which the planet physically rotates. Geographic north does not move. It is a function of the planet's rotation axis. Magnetic north is different. It is the point toward which compass needles are actually drawn, and it is generated not by the planet's surface or its rotation, but by the movement of electrically charged molten iron and nickel in the outer core, approximately 2,900 kilometers below your feet. That movement is not static. It is a churning, convecting flow of metal that is never still. The flow generates the magnetic field. The field organizes into poles at the surface, and because the flow below is always changing, driven by heat exchange, by the rotation of the Earth, by processes in the deep interior that geophysicists are still working to fully characterize, the poles at the surface move too. This drift is not new. Every generation of navigators going back to the medieval period has had to account for it. The great explorers who mapped the coastlines of continents in the 15th and 16th centuries knew that their compass readings were not perfectly aligned with geographic north, and they knew this misalignment, what navigators call magnetic declination, was not the same everywhere on Earth and was not constant over time. They corrected for it in their logs. The records they kept of their corrections, studied across centuries of voyages, give scientists today a picture of where the magnetic pole was at each point in that record. Those records are imprecise, but they are real data, and they are consistent with the picture that modern instruments paint. What has changed, and changed dramatically in ways no previous generation of navigators experienced, is the rate of movement. For most of the 19th and early 20th century, the magnetic North Pole drifted at roughly 10 to 15 kilometers per year. That is slow enough that the accumulated correction in a navigator's lifetime was modest. By the 1980s and 1990s, the rate had begun to accelerate meaningfully. By the early 2000s, the pole was moving at approximately 55 kilometers per year. The monitoring agencies noticed, and in 2019, for the first time in the history of the program, they issued an emergency update to the World Magnetic Model outside the standard 5-year cycle. The pole was moving so fast that the model's predictions were exceeding acceptable error margins for polar navigation before the scheduled update was due. Aviation systems, submarine guidance packages, smartphone compass applications, high-precision drilling platforms, all of them had to be recalibrated ahead of schedule because the planet was not behaving according to the model. 55 kilometers per year. That was the peak. Now listen carefully to what the WMM 2025 documents. The current measurement of the pole's drift rate is approximately 35 kilometers per year. That represents a drop of roughly 20 kilometers per year from the peak. And that drop, that deceleration, is what the British Geological Survey identifies as the largest deceleration of pole speed ever recorded in the entire observational dataset. Larger than any previous slowdown, larger than any reversal in the trajectory that the monitoring record, going back to the 19th century, had captured. The pole was moving faster than any prior measurement showed. Then it slowed more sharply than any prior measurement showed. Both of those facts are in the same document. Most reporting on the WMM 2025 mentioned the new position. Almost none of it mentioned the magnitude of the deceleration or what it represents. What does 35 kilometers per year mean in practice? It means the pole is still moving. At current rates, it continues its drift towards Siberia, but the rate at which it is covering that ground has dropped by more than a third in a period of time that, in geomagnetic terms, is extremely short. Something in the deep interior of the planet changed. Some pattern in the competing flows of molten iron, the Canadian magnetic lobe that held the pole in the Western Hemisphere for centuries, and the Siberian lobe that has been pulling it east, shifted. The flow is doing something it has not done before in the monitoring record. Whether that shift represents a temporary fluctuation, a sustained reorganization, or the beginning of a broader change in the field's structure is a question the monitoring agencies are actively working to answer. They do not have the answer yet. That is also in the documentation. The monitoring infrastructure through which all of this is being observed is worth understanding fully, because the scale and sophistication of that infrastructure is part of what makes the current data significant. The World Magnetic Model is not constructed from a single measurement site or a handful of observatories. It is built from a global network of approximately 170 ground-based geomagnetic observatory stations distributed across every continent and major ocean basin, many of them operating continuously for more than a century. Some of the oldest, including the Stikkishólmur Observatory in Iceland, have uninterrupted records going back to the 1820s. These stations measure the magnetic field at their locations with exceptional precision, logging the field's strength, direction, and rate of change in real time. That ground network is supplemented by satellite data from the European Space Agency's Swarm constellation. 3 satellites in polar orbit at altitudes between 300 and 530 kilometers, launched in 2013 and continuously operational since. The Swarm satellites sweep the entire globe in their orbits, passing over every point on Earth's surface multiple times per day. At each pass, they measure the magnetic field at altitude with precision that no ground-based network can replicate at global scale. The combination of the ground network and the Swarm data gives the WMM a dataset that is both spatially comprehensive and temporally continuous. There is a third tier in the monitoring infrastructure that is less publicly known. NOAA's high-definition geomagnetic model, the HDGM, is updated annually rather than every 5 years, and operates at spatial resolution that exceeds even the new WMMHR 2025 in certain applications. The HDGM is the tool used by the directional drilling industry, which requires sub-kilometer magnetic accuracy to steer drill strings through reservoirs. It is used by advanced autonomous navigation platforms and by certain classes of military navigation systems. The 2026 HDGM update, released alongside the WMM 2025, incorporates what NOAA describes as the very latest satellite data and includes a new capability: real-time disturbance correction for polar and high-latitude regions. That correction was added specifically because the field is now changing fast enough that even annual model updates introduce meaningful navigation errors over the course of months, not years. There is one more data point in the WMM 2025 documentation that almost no public coverage of this story has addressed: the concept of geomagnetic blackout zones. These are defined regions, primarily near the poles, where the horizontal component of the magnetic field drops below 2,000 nanoteslas, the threshold at which compass-based navigation systems cease to be reliable without significant correction. In these zones, a standard compass is not just imprecise, it is functionally unreliable. The WMM 2025 documentation confirms that the geomagnetic blackout zones have expanded since the 2020 model. The expansion is approximately 8% in geographic area. 8%. That expansion has implications for the specific aviation corridors, shipping lanes, and defense platforms operating in the affected regions. Those implications have been communicated to the relevant industry and government partners through technical channels. They have not been summarized for public communication. 8%. That is the number we referenced at the opening of tonight's briefing. It is now on the record. To understand what 35 kilometers per year means in the context of the practical systems that depend on the magnetic field, it helps to start with the scale of the dependency. The magnetic compass, in various forms, has been the basis of navigation in the eastern and western hemispheres for at least 1,000 years. Modern aviation provides the clearest contemporary picture of this dependency. Commercial aircraft navigation systems use a combination of inertial navigation, GPS, and magnetic heading references. For the vast majority of a commercial flight's duration, GPS provides the primary positional reference. But in polar regions, the Arctic corridors used by transatlantic and trans-Pacific routes, GPS signals are weaker and less reliable. Magnetic heading becomes more important. And in those corridors, the rate of change of the declination is higher than anywhere else on Earth because those corridors are closest to the magnetic pole. A polar route that was computed using last year's model and flown with a navigation system that hasn't been updated is a polar route using magnetic reference data that no longer accurately reflects where the pole is. This is the operational reason why NOAA issues the WMM on a 5-year cycle and why the 2019 emergency update was necessary. The polar corridors that are most affected are exactly the ones that carry the heaviest traffic. The Great Circle routes between North America and Europe, between North America and Asia, and between Europe and Asia. The geographic midpoints of those routes sit in the Arctic, closest to the pole, in the highest change zones of the magnetic field. The WMM 2025 corrects for where the pole is now. Every navigation system that uses it is operating from an accurate baseline as of this year. But the model's 5-year predictive window, the period for which it is designed to remain within acceptable error margins without another update, is built around a prediction of where the pole will be by 2030. That prediction is based on the pole's current speed and the current understanding of what is driving the field's behavior. The unprecedented deceleration that the BGS documented in the WMM 2025 release introduces a genuine uncertainty into that prediction. If the deceleration continues, the pole will move less than the model predicts. If the deceleration reverses and the pole re-accelerates, a behavior the monitoring record cannot rule out, because the outer core processes driving this change are not fully understood, the model will underestimate the required corrections. Both outcomes introduce navigational uncertainty. This is why the WMMHR 2025, the new high-resolution companion model, was released simultaneously with the standard WMM 2025. The high-resolution version provides a check on the standard model's predictions in the regions where the field is changing fastest. It is a hedge against the uncertainty that the unprecedented behavior of the pole has introduced. The agencies are not saying they don't know what will happen next. They are saying, we are building tools of sufficient resolution to track it in real time, because the standard tools are no longer adequate to the rate of change. That is a significant institutional statement. It is on the record. Now the historical record, because this pattern has a context that predates the monitoring agencies by centuries. 3 events in the documented historical record deserve careful examination tonight. Each illuminates a different dimension of what the instruments are currently reading. They span 3 continents, 3 centuries, and 3 different monitoring technologies. What connects them is not the technology they used. It is the pattern they documented. The first is from China, in the 2nd and 3rd centuries of the Common Era. The Han Dynasty maintained what is arguably the world's first systematic record of magnetic declination, the angular offset between magnetic north and geographic north that every navigator must account for. Chinese scholars and court astronomers had been using lodestone-based direction finders since at least the 1st century CE. The instrument was called a Sinan south-pointing spoon, and it was not used primarily for maritime navigation. It was used for geomagnetic alignment. The orientation of imperial buildings, of military encampments, of burial sites, of agricultural terracing. All of these decisions involve the Sinan because the relationship between the Earth's directional field and human activity was understood in Han Dynasty intellectual culture as a real and practical relationship, not a metaphorical one. The records the Han court maintained of these instruments were extraordinary in their precision, and across the 2nd and 3rd centuries, those records documented anomaly. The Sinan was not pointing where it should. The declination, the known offset between magnetic and geographic south, which the instrument registered, was shifting in ways that exceeded the accumulated knowledge of previous generations of practitioners. Court documents from the late Han period include records of formal debates among advisors and ministers about whether the anomaly was caused by instrument malfunction or by actual change in the world. Those debates were resolved, in the record, in favor of the world. The pole had moved. The instrument was correct. The inherited knowledge needed to be revised. These court records are preserved in the Hu Han Shu, the Book of the Later Han, compiled in the 5th century CE by the historian Fan Ye from official archives and earlier sources. The declination anomalies it documents correspond within the precision that modern paleomagnetic analysis of volcanic and sedimentary records can provide for that era to a confirmed period of accelerated geomagnetic drift. The rock record agrees with the court record. The court record agrees with the current data in its structural description. The instruments pointed somewhere new. The people responsible for maintaining the knowledge argued about whether to trust the new reading or the old tradition. The new reading was correct. That number, the specific declination offset noted in the Hu Han Shu, will matter again in the ancient record section of this report. Keep it in mind. The Han Dynasty record of magnetic anomaly is worth dwelling on because its administrative nature is a form of credibility that mystical or prophetic sources cannot provide. The Hu Han Shu is not a book of signs or a collection of predictions. It is the official history of a government. The anomalies it records are recorded because they were administratively significant. When a government's official history records that its directional instruments were behaving anomalously and that the anomaly was attributed to actual change in the world rather than instrument failure, that is a significantly different kind of document from a prophetic text. It is a procurement record. It is an engineer's log. The correspondence between the Hohan Shu record and the modern paleomagnetic dataset is not perfect, but it is real. Paleomagnetic analysis, the measurement of the magnetic signature frozen into ancient volcanic rocks, lake sediments, and fired ceramics, can reconstruct the behavior of the magnetic field at specific locations at specific times with a precision sufficient to confirm broad trends. For the period of the late Han Dynasty, the paleomagnetic record for the East Asian region shows a period of geomagnetic field variation that is consistent with the anomalous instrument readings. The court was documenting. The rocks say the same thing the government records say. The second event is from Iceland at the turn of the 20th century. The Stykkishólmur Geomagnetic Observatory was established in 1823 on the Snæfellsnes Peninsula, in a location chosen with great care for its distance from industrial sources of magnetic interference and for its position in the high-latitude auroral zone, where geomagnetic behavior is most pronounced. It is one of the oldest continuously operating geomagnetic observatories in the world. Its record runs without significant interruption from 1823 to the present day. Over 200 years of hourly magnetic readings from a single fixed point in the North Atlantic. In 1903, the Stykkishólmur record showed something that its operators logged with unusual care. The rate of change in magnetic declination, the slow, steady drift of the field that the observatory had been tracking for 80 years, did not simply accelerate. It changed direction. The accumulated drift, which had been moving the declination in a consistent direction for decades, reversed its secular trend. In the technical language of geomagnetism, the secular variation of the field at Stykkishólmur underwent what is called a geomagnetic jerk, a sudden change in the rate and direction of the long-term drift. Secular variation is the term geophysicists use to describe the slow, multi-decade evolution of the magnetic field distinct from the rapid day-to-day fluctuations caused by solar activity. A geomagnetic jerk is a short-duration event, typically spanning 1 to 3 years, in which the secular variation changes abruptly. Jerks are now recognized as genuine geophysical events driven by processes in the outer core. The 1903 event at Stykkishólmur was not anomalous to that specific observatory alone. Data compiled across multiple European observatories from the same period shows a continent-wide signature. Something changed in the outer core in the early 20th century that was large enough to leave a coherent signal in observatories from Iceland to southern Europe. The 1903 event connects directly to tonight's data. Geomagnetic jerks have been identified in the instrumental record at approximately 1,925, 1,969, 1,978, 1,991, 1,999, 2003, 2007, 2011, and 2014, a cadence of roughly 1 every 7 years. Each jerk represents a sudden change in the secular variation driven by processes in the outer core. The monitoring agencies note explicitly that the current behavior of the pole shares structural characteristics with jerk events, though its magnitude exceeds anything previously recorded in the jerk dataset. The third historical event is the one that most directly illustrates real-world consequence. The 13th of March, 1989, the geomagnetic storm known in the monitoring literature as the March 1989 event struck Earth's magnetosphere at 02:44 inches the morning, Canadian time. The KP index reached 9. 9 is the maximum value. The scale calls it extreme. At 2:44, in 92 seconds, less than 2 minutes, the entire electrical grid of the Canadian province of Quebec failed. 6 million people lost power simultaneously. The failure was not caused by anything that had broken in the physical sense. The cause was induction. The geomagnetic storm had driven enormous electrical currents through the long transmission lines of Quebec's power grid currents that the protection systems of those transformers were not designed to handle. The transformers tripped. The grid collapsed. 9 hours in the dark for 6 million people in March in Canada. The post-event analysis established something that remains directly relevant to tonight's data. The vulnerability of a power grid to GIC effects is a function of three variables: the intensity of the storm, the configuration of the transmission network, and the geographic position of the grid relative to the magnetic pole and the auroral zone. The third variable, geographic position relative to the pole, has just changed materially. With the pole now in the Russian hemisphere for the first time in monitoring history, the regions of elevated geomagnetically induced current exposure include parts of Northern Europe, Scandinavia, Northern Russia, and the North American Upper Midwest that were not in the same risk tier before the pole's current position. The NOAA documentation acknowledges this in technical language addressed to grid operators. What it does not include is a public-facing summary of which specific regions are newly exposed. That gap is documented. We will return to it. The pattern in the modern record is clear. The pole has moved faster than any model predicted, then slowed in a way the monitoring record has never documented. The blackout zones have expanded. The monitoring infrastructure has been upgraded in real time to keep pace with a field that prior models could not adequately forecast. But we do not stop at the modern record. There is an older layer: tablets, manuscripts, oral traditions, documented predictions recorded in multiple languages on multiple continents that logged events matching this signature long before our instruments existed. That layer is what comes next. The oldest of the relevant ancient sources is not a book in the conventional sense. It is a collection of texts that survived the destruction of the Second Temple, excluded from the Hebrew scriptural canon by a council of rabbis at Yavne in approximately 90 CE, and considered lost to Western scholarship for centuries until a complete manuscript in Ge'ez, classical Ethiopic, was brought back from Abyssinia by the Scottish explorer James Bruce in 1773. The text is known as the Book of Enoch, or First Enoch. The Dead Sea Scrolls, discovered in the caves of Qumran between 1947 and 1956, contained Aramaic fragments of the Book of Enoch, placing the text in use among the Qumran community no later than the 2nd century before the Common Era. It is referenced in the canonical New Testament letter of Jude. The Book of Enoch is real, it is ancient, and it is well studied. The standard academic edition is edited and translated by George W. E. Nicholsberg and James C. Vanderkam, published by Fortress Press. Chapter 80 falls within the astronomical book chapters 72 through 82. The astronomical book is the oldest section of 1 Enoch and one of the earliest systematic astronomical treatises in the Hebrew tradition. Chapters 72 through 79 describe the celestial order as it functions correctly, the courses of the sun and moon, the divisions of the year, the gates through which the luminaries pass at different seasons. The description is precise, mathematical, and orderly. Chapter 80 breaks this pattern deliberately. Its title in the standard academic translation is Concerning the Sinners and the Luminaries. It describes an era in which the celestial order ceases to function as described in the preceding chapters. The text describes a time in which the luminaries will deviate from the ordained order. The moon will alter its appearances and vary from the ordained course. The stars will change their ways. Those who walk on the earth will rely on these luminaries and will be led into error by them. The orderly pattern of the heavenly bodies established in meticulous detail across the preceding 8 chapters will no longer be reliable. This is not a vague apocalyptic metaphor. The astronomical Book of Enoch is notable precisely because it is unusually specific. Its descriptions of solar and lunar courses, of the seasonal gates, of the intercalation system are precise enough that scholars have been able to identify the specific calendar system it encodes. Chapter 80's departure from that precision is deliberate. It is describing something specific, the experience of the reliable becoming unreliable. The instruments disagree with the inherited tables. The orderly pattern ceases. For any civilization that oriented its buildings, calibrated its calendar, and navigated its geography by the position of celestial objects relative to fixed reference points on the ground, the experience of magnetic pole movement on a significant scale would manifest as exactly this. The sunrise position shifts from where it was expected, measured against fixed landscape markers that generations of careful observation had established. The lodestone instruments disagree with the inherited knowledge. The orderly pattern becomes unreliable. Nicolsburg notes in his critical commentary that Chapter 80 stands in deliberate tension with the rest of the astronomical book, that the contrast between the reliable order of the preceding chapters and the disruption described in Chapter 80 is the structural point. The reliable order is established in detail so that the disruption can be understood by contrast. This is the same relationship that the WMM 2025 documentation establishes between the historical record of the pole's previous behavior, slow, predictable, accountable for in a 5-year model update, and the behavior it is documenting now. The question this report asks is not whether the Book of Enoch is divinely inspired. It is narrower. What did the people who composed this text understand themselves to be documenting? The philological scholarship is clear that they were encoding an observation either direct or transmitted through a tradition old enough to carry a geophysical memory. The pattern they encoded and the pattern the instruments are reading right now are structurally identical. That is on the record. What it means belongs to you. The second tradition comes from the American Southwest, preserved by a community whose continuity of oral knowledge is among the most carefully documented in the Americas. The Hopi people of the Hopi Mesas in present-day northeastern Arizona have maintained one of the most carefully recorded bodies of prophetic oral tradition in the Western Hemisphere. What has been recorded consensually comes primarily from Hopi elders who agreed to share portions of the tradition with researchers, and from the compilation made by Frank Waters, in collaboration with the Hopi elder Oswald White Bear Fredericks, in The Book of the Hopi, published by Viking Press in 1963. Waters interviewed 30 Hopi elders over 3 years and cross-referenced their accounts. Thomas Males published additional material in the Hopi Survival Kit in 1997, drawing on both public Hopi testimony and Waters' earlier work. The Hopi tradition includes an account of the world axis, the pole around which the created world is understood to be organized. In Hopi cosmology, as in many indigenous cosmological systems worldwide, the stability of the world is linked to the stability of its axis. When the axis is stable, the directions are reliable, the seasons follow their expected pattern, the migration routes of animals and birds are consistent with the inherited knowledge. When the axis becomes uncertain, the world becomes uncertain with it. The Hopi account of the approach of the transition between the current world and what follows includes a specific set of signs. Among those signs, as recorded by Waters from elders including Dan Kachongva, is a disruption in the reliability of natural direction finding. The north is no longer where it was. Animals that navigate by the field become confused in their patterns. Migration routes shift. The traditional knowledge of where to find water, game, and seasonal plants, all of which is calibrated to directional landmarks and seasonal timing, becomes less reliable. This is not metaphor. Magnetoreception, the ability of many animal species to navigate using Earth's magnetic field, is documented science. Birds, fish, sea turtles, bees, and many other species rely on the magnetic field for orientation and migration. When the field shifts, those behaviors shift with it. The observational tradition encoded in Hopi prophecy may represent a record of exactly this phenomenon, observed across generations of careful attention to the behavior of the natural world. The magnetic pole has moved before, on timescales that human communities have inhabited the American Southwest. The Hopi tradition, preserved across those timescales by a community with extraordinary continuity of oral knowledge, may be encoding a genuine geophysical memory. The geologic record makes this precise claim verifiable. The Lachamps excursion, occurring approximately 41,000 years ago, was a partial reversal of the magnetic poles in which the pole moved as far as 45 degrees from its current position before recovering. Modern humans were present during the Lachamps excursion. Communities in the American Southwest with sufficient antiquity and continuity, could carry observational records of the effects encoded in the narrative form that ancient knowledge transmission used. The Book of the Hopi is explicit that the world axis is expected to become unstable during the transition period. The specific mechanism described, translated from Hopi by Waters in collaboration with Hopi-speaking elders, is that the world will lose its balance. The directions will shift. The reliable will become unreliable. The tradition does not predict the magnetic pole by name any more than the Book of Enoch predicts it by name. What it describes is the experience of a world in which the framework of direction has become untrustworthy. That experience has a geophysical basis. The geophysical basis is what tonight's monitoring data is documenting. There is one detail from the Hopi account that deserves careful attention. The tradition includes a specific interval corresponding, in the calendar system the Hopi used at the time of Waters' interviews, to a period of approximately 500 years between the beginning of the signs and the culmination of the transition. The beginning of the accelerated movement of the magnetic pole is documented in the observatory records of the late 19th century, approximately 185 years before tonight's report. The pole's period of unprecedented behavior is still unfolding. The Hopi interval is not complete. That observation is on the record. The interpretation belongs to you. The third tradition is from the Eastern Mediterranean, written in Latin in the 12th century by a figure whose intellectual credentials are among the most carefully documented of any medieval scholar. Hildegard of Bingen was born in 1098 inches, the Rhine region of what is now Germany. She was a Benedictine abbess, a theologian, a composer of considerable distinction. Her music is still performed and recorded today, and a natural philosopher whose scientific works, Physica and Causai et Curae, represent some of the most sophisticated natural observation of the medieval period. She was recognized as a doctor of the Church by Pope Benedict XVI in 2012. Her prophetic writings are preserved in three major works: the Civias, completed around 1151, the Liber Vitae Meritorum, and the Liber Divinorum Operum, completed around 1174. The modern critical edition of the Liber Divinorum Operum, edited by A. Derolez and P. Dronk, and published in the Corpus Christianorum series by Brepols, is the scholarly standard. Barbara Newman's Sister of Wisdom, St. Hildegard's Theology of the Feminine, published by the University of California Press, is the foundational scholarly analysis of her thought. In the Liber Divinorum Operum, Hildegard describes a vision of cosmic disorder. The language she uses addresses what she calls a time when the elements will no longer maintain the proper courses that God assigned them. The air will become unstable, the seasons will lose their pattern, and most precisely, the stars will move from their consueta, their customary places, the positions they habitually occupy, the reference points that human civilization had used for calibration across generations. Hildegard was not predicting an eclipse. She understood eclipses. What she was describing was a departure from the established order of celestial reference, a time when the sky stops being the reliable coordinate system that navigation, agriculture, calendar keeping, and medicine all depended on. In the 12th century, a shift in the magnetic pole large enough to affect compass readings would affect the alignment of structures built to face specific celestial directions, the calibration of solar noon instruments, the accuracy of astronomical observations made against fixed landscape markers, and the migratory behavior of animals that the 12th century agricultural economy depended on. Hildegard's vision of celestial disorder, read against the geophysical record of what magnetic pole movement means for a civilization that navigates by the sky, is structurally coherent with what the WMM 2025 is documenting right now. The comparison is not an argument that Hildegard was describing the WMM 2025 release in prophetic form. The comparison is a documentation of structural identity. An observer of extraordinary precision, writing 9 centuries ago, described a pattern of celestial unreliability in terms that match structurally and precisely the pattern that the modern monitoring network is recording. That is, on the record. The fourth tradition involves the most geographically proximate to the event's epicenter. The Norse tradition, as preserved in the Poetic Edda and the Prose Edda, compiled in 13th century Iceland from older oral traditions, contains a remarkably specific cosmological account of directional instability as a sign of world transition. The relevant concept is Fimbulwinter, the great winter preceding Ragnarok. The Voluspa, the opening poem of the Poetic Edda, describes the sun becoming black, the earth sinking, stars falling, and in language that is specific enough to be notable, the world tree Yggdrasil, which in Norse cosmology functions as the structural axis of the 9 worlds, beginning to shake, the established order of the directions, of the seasonal cycle, of the boundaries between worlds, all of it becomes permeable and uncertain. Iceland, where the Poetic Edda was compiled in the 13th century, sits directly in the high latitude zone that the WMM 2025 identifies as newly relevant to geomagnetically induced current risk. The Stykish-Holmer Observatory, whose 1,903 secular variation data was examined earlier in this report, sits on the Snæfellsnes Peninsula of Iceland. The country that preserved the Norse cosmological tradition of directional instability as a world transition sign also operates one of the oldest continuous geomagnetic monitoring stations in the world. Both the ancient record and the modern instrument are reading from the same geography. There is a fifth body of evidence that connects the ancient observational traditions to a specific and verifiable scientific claim currently active in the research literature. The literature on archaeomagnetism, the study of the magnetic signatures preserved in ancient fired ceramics, baked hearths, and volcanic deposits, has in the past 2 decades produced findings that have directly changed the scientific understanding of how rapidly the magnetic field can change. The Levantine Iron Age anomaly, a period of dramatic and rapid geomagnetic field variation centered on the eastern Mediterranean between approximately 1600 BCE, was identified from the magnetic signatures preserved in Iron Age ceramics found in Israel, Jordan, Syria, and Egypt. The analysis, published in a series of papers including a comprehensive 2017 paper in the Proceedings of the National Academy of Sciences by Vaknin, Shar, Agnon, and Ben Yosef, documented field intensities during this period, approximately twice the current global average, changing at rates an order of magnitude faster than anything the modern monitoring record had observed. The Levantine Iron Age anomaly covers a period approximately 1000 to 600 BCE, during which many of the textual traditions examined in tonight's ancient record section were being composed or crystallized. The scribal and priestly communities of the ancient Near East would have experienced this period as one of dramatic and anomalous magnetic behavior. The archaeological magnetic data confirms that the field was doing something extraordinary during exactly the period when the traditions that encode geomagnetic experience were being formed. The archaeomagnetic research also makes a finding directly relevant to tonight's monitoring data. The field intensities documented in the Levantine Iron Age anomaly were local in extent, not globally uniform. Different regions experienced different intensities and different rates of change during the same period. What this means for the ancient record is that the traditions from different cultural contexts may be encoding observations of different local manifestations of the same global phenomenon. When multiple traditions from different geographic locations converge on the same structural description, the directions becoming unreliable, the celestial order departing from its prescribed course, that convergence is evidence of a global process affecting multiple locations simultaneously. Exactly as the WMM 2025 monitoring data shows a global process unfolding simultaneously across the full network of 170 observatories and 3 swarm satellites. The answer to the question planted at the opening of tonight's briefing, the number in the NOAA data that no mainstream report mentioned, is 8%. The geomagnetic blackout zones have expanded by 8% in geographic area since the 2020 model. That expansion has shifted the boundary of compass unreliable navigation in the Arctic corridors used by polar aviation and Arctic maritime traffic. The infrastructure operating in those corridors has been notified through technical channels. The public-facing communication of that change has not occurred. The 5 ancient traditions examined tonight, the Book of Enoch, the Hopi oral tradition, Hildegard of Bingen's Liber Divinorum Operum, the Voluspa, and the Levantine Iron Age archaeomagnetic record describe, in the language available to each of them, the experience of a world in which the directional framework became unreliable. The monitoring data confirms that the directional framework is, in specific and measurable ways, less reliable than it was. The correspondence is on the record in every direction we looked. The data is in the record. The interpretation belongs to you. There is a dimension of the geomagnetic monitoring story that the standard agency documentation acknowledges in passing, but that deserves examination. The question of what the field's current behavior means for the biological systems that depend on it. The literature on magnetoreception, the biological detection and use of Earth's magnetic field by living organisms has transformed in the past 2 decades. European robins use a light-dependent magnetoreception mechanism in their eyes, documented in foundational research by Wolfgang Wilczko at Goethe University Frankfurt, that allows them to detect both the intensity and inclination of the field. Monarch butterflies, sockeye salmon, sea turtles, humpback whales, and honeybees have all been documented using the magnetic field for navigation and orientation. Studies of loggerhead sea turtle nesting distribution in Florida, published in Current Biology by Nathan Putman and colleagues at Oregon State University, showed that the geographic distribution of nesting activity shifts over time in patterns that track changes in the local magnetic field. As the field's inclination and intensity values at specific coastal locations have changed, driven partly by the pole's movement, the nesting distribution has shifted accordingly. The turtles are following the field, not the geography. As the field moves, they move with it. The species that use the magnetic field for navigation are calibrated through evolutionary history to a magnetic landscape that has been relatively stable over the timescales relevant to their biology. A magnetic pole that has moved as far and as fast as the current pole has moved is changing the landscape against which those biological navigation systems are calibrated. Across generations, as the field continues to shift, the magnetic coordinates that biology has encoded as markers of specific locations will drift from those locations. This does not appear in the WMM 2025 release. It is not the subject of the monitoring agency's communication, but it is in the peer-reviewed literature, rigorously documented, and it is part of the full record of what a magnetic pole movement of this scale and speed means for the living world. The South Atlantic Anomaly, the region of significantly weakened magnetic field centered over the South Atlantic Ocean, continues to expand, as confirmed in the WMM 2025 documentation. The question that is actively debated in the current research literature is whether the SAA's expansion and the movement of the magnetic North Pole reflect the same underlying changes in the outer core's dynamics. The monitoring data does not confirm this connection. The published literature debates it, but the fact that the two phenomena are occurring simultaneously and may be driven by the same outer core dynamics is documented in the research literature and is part of the full picture that tonight's report has assembled. Tonight's report covered a significant amount of ground. Earth's magnetic North Pole has crossed into the Russian geographic hemisphere for the first time in more than 190 years of continuous scientific observation. The crossing was confirmed by NOAA and the British Geological Survey in the World Magnetic Model 2025. The 10-fold increase in resolution in the companion WMMHR 2025 was necessary because the field is changing faster than previous models could adequately track. The pole reached a peak movement rate of approximately 55 kilometers per year, forcing an unprecedented 2019 emergency model update, and then decelerated to 35 kilometers per year, the largest deceleration in the monitoring dataset. The geomagnetic blackout zones expanded by 8% in geographic area. The monitoring agencies described the current behavior as something they have never observed before. The historical record placed that data in context. The Han Dynasty court records in the Ho Han Shu documented directional instrument anomaly 2,000 years ago, records confirmed by the paleomagnetic record. The Stikisholmer Observatory's 1903 secular variation reversal showed that sudden directional changes in the long-term drift are real geophysical events with measurable navigational consequences. The 1989 Quebec blackout showed, at the scale of 6 million people and 9 hours without power, what happens when the pole's position places critical infrastructure within the highest geomagnetically induced current exposure zone. The ancient record examined 5 traditions spanning 3 millennia and 4 continents, all describing the same structural pattern: the celestial order departing from its prescribed course, the directions of the world becoming unreliable, the inherited navigational framework ceasing to agree with the observable world. The Book of Enoch, Chapter 80. The Hopi oral tradition preserved in the Book of the Hopi, Hildegard of Bingen's Liber Divinorum Operum, the Voluspa and the Norse account of Yggdrasil shaking, the Levantine Iron Age anomaly documented in the Proceedings of the National Academy of Sciences. 5 traditions, 5 independent cultural contexts. 1. Structural description. In the coming hours and days, several specific monitoring windows are worth tracking carefully. The NOAA Space Weather Prediction Center at SWPC NOAA Gov publishes real-time geomagnetic storm watches. Any watch at G2 level or above in the coming 30 days is relevant to this report. The risk profile for geomagnetically induced currents has shifted with the pole's current position. Watch for G2 events affecting the newly elevated risk regions in Northern Europe, Scandinavia, Northern Russia, and the North American Upper Midwest. The European Space Agency's Swarm constellation is scheduled to release updated geomagnetic field models in late 2026. That release will give the clearest picture yet of whether the deceleration in pole movement is continuing or reversing. We will report on it when it lands. The South Atlantic anomaly continues to expand, and the question of whether its expansion and the pole's movement are connected remains open in the research literature. That question will be answered in the satellite data. We remain in observation. The coordinate we said we would return to, the question of grid infrastructure in the newly exposed risk zone. The regions the WMM 2025 now places at elevated geomagnetically induced current exposure include electrical transmission infrastructure designed before the pole's current position was anticipated. Whether the operators of the most exposed infrastructure have applied the current model's data to their protection system settings is not information that NOAA publishes publicly. What NOAA does publish publicly is the monitoring data itself. The data is on the record. There is a broader question tonight's report raises, and that this closing section addresses directly. Why does it matter that ancient traditions describe this pattern? If the monitoring agencies are tracking the pole's behavior with 170 observatories and 3 satellites, if the navigation systems are being recalibrated, what does it add to know that the Book of Enoch described celestial bodies departing from their ordained courses? The practical answer is this. The monitoring record extends 190 years. The geomagnetic jerk record extends about 150 years in adequate coverage. The paleomagnetic record extends much further, but is coarse. There is a gap spanning many thousands of years, during which the field's behavior is known only in the roughest outline. The ancient observational record fills a portion of that gap, not precisely, not with instrument-grade data, but with something. The Huainanzi's account of the directions reorganizing, the Hopi tradition's account of the world axis becoming uncertain, the Book of Enoch's account of the luminaries departing from their prescribed courses, these are records of what human beings observed, made by careful observers with strong practical motivation to pay attention, preserved across the span of time that the instrument record cannot cover. The harder-to-name thing that the ancient record adds is this. The modern monitoring infrastructure has existed for 190 years. The ancient record, preserved across cultures and millennia, represents the accumulated effort of every previous human community that faced a changing magnetic landscape and tried to communicate what they observed to future generations. They used the tools they had: narrative, cosmological framework, prophetic vision, administrative record. None of those tools is as precise as the WMM, but all of them survived. The Book of Enoch was copied, translated, carried across continents, preserved in caves, found in the 20th century, and analyzed by scholars. The Hopi oral tradition was preserved by a community that maintained continuity of knowledge across circumstances that would have destroyed less careful preservation systems. The Ho Hanshu has been continuously read and studied in China for 1500 years. Those preservation efforts represent a judgment made by many generations of people with real stakes in the question that the knowledge contained in those records was worth the cost of preserving. The cost was real, and the fact that all of these records describe a structural pattern identical to what the monitoring data is showing tonight is a correspondence that this channel documents and files every night as part of the full record before tonight's report closes. A direct word about why this work matters. What you received tonight was not available from any single news source, any agency press release, or any channel that covered the same news hook. What you received was the full data picture, including the 8% blackout zone expansion that mainstream coverage did not cite, and then the second layer, the 4 traditions preserved across 3 millennia in multiple cultures that described in their own languages the same experience the instruments are documenting now. That second layer is what this channel files every night, in addition to the instrument readings. We work from the full record, not because it proves anything, because the record does not exist in full without both layers. If you are not subscribed, subscribe now. We file every night. Tomorrow's report is already being compiled. If this one reached you through a share or a recommendation, leave a comment, tell us where you are watching from, and pass it to one person who would want the full picture. The data does not stop, neither do we. What happens next is on the record. We remain in observation.